This is section 11.5 in your textbook on rationalizing denominators. It is considered improper to have radicals on the denominator of an expression. So any square roots, cube roots, anything like that on the denominator is considered improper. And so in order to fix this, we do something called rationalizing. We rationalize the denominator using multiplication so that it no longer contains a radical. So we're going to do a few of these and you'll start to pick up on the pattern, and hopefully these aren't too bad for you. So if I have radical 3 divided by radical 2, I cannot have radical 2 on the denominator. So what I'm going to do is multiply the top and the bottom by radical 2. So whatever radical's on the denominator, that's what I'm going to multiply on the top and the bottom. That process is called rationalizing the denominator. Radical 3 times radical 2 is radical 6. Radical 2 times radical 2 is radical 4. But because it's a perfect square, that really just gives me 2. So radical 6 over 2 is the same expression, but no longer improper. It's been rationalized. Let's try the second one. 2 over the square root of 5. I'm going to multiply the bottom and the top by radical 5. That's going to give me 2 radical 5 on top. Doesn't really matter what's on top. Then radical 5 times radical 5 is radical 25. But because that's a perfect square, I can just put 5. And now there's no longer a radical on the denominator. So what I want you to notice, and it might take you a few more to notice this, is that radical 2 times radical 2 is just 2. The radicals, if they're square roots, kind of cancel each other out. That's not really what's happening, but that's kind of what it looks like. Radical 5 times radical 5 is just 5. So you'll see that a few more times, and hopefully you can kind of skip that step. I'm hoping you can start to skip that step and go straight from here to there. If you're not comfortable with that yet, that's okay. See it a few more times and then you can see what I'm talking about. Let's try the next two. So we're going to use the quotient rule to separate these two. And then we're going to rationalize the denominator by multiplying the top and the bottom by the bottom. It's kind of like flipping and multiplying, but not really, because you're just doing the same thing up and down. Kind of like making common denominators on fractions. So we have radical 7x times radical 3y. That would be radical 21xy on top. And then radical 3y times radical 3y is just 3y. You really get radical 9y squared, but the square root of 9 is 3, and the square root of y squared is y. So again, I'm hoping you can skip this part at some point. You'll see that when two square roots are multiplied together and they're the same, you just get what's underneath the radical. Let's try that again on this one. So that would be your final answer on that one. Here we're going to use the quotient rule first. Separate 3z from 5y. Then we're going to rationalize the denominator by multiplying the top and the bottom by the denominator. Radical 3z times radical 5y is going to be radical 15. You can put zy or yz. I think they prefer it alphabetical, so you can put them in the other order. Over radical 5y times radical 5y is just 5y. So they might want square root of 15yz alphabetically over 5y. So again, two radicals that are square roots multiplied together, you just get what's underneath the radical. Alright, let's look at some more of these. We have 2 radical 16 over radical 9x. If you can simplify first, you don't have to, but the numbers get smaller and much easier to work with. So when I see radical 16, it's much easier to work with it if it's just 4. And 2 times 4 is 8. And when I see the square root of 9, well, that's just 3. And then the only thing that's really under a radical is x. So if I can simplify that first, I only have to multiply by radical x. I can multiply by radical 9x, but then you have a lot more work to do and you get down to the same answer. So when you notice it, if you have perfect squares, try to clean them up first and then proceed to just multiply only by what's in the radical. So it's going to give us 8 radical x, and then we'll have the 3, and radical x times radical x is just x. So those two multiplied together is just x. And now it's rationalized. There's no more radicals on the denominator. Same idea with the next one if you want to try it on your own first. We have perfect squares. So the radical 25 is really just 5. And 3 times 5 is really just 15. Radical 4 is just 2. So the only part under the radical is x. And so when I rationalize, I only have to multiply by radical x, which just makes things a lot easier. So my final answer would be 15 radical x over 2x. And hopefully you're seeing that pattern. Radical x times radical x is just x. This saves you a little bit of time and mental energy. Let's try the last two here. Again, I'm going to try to simplify that radical first. I know that's 9 times 2. So that's 3 radical 2. So what I really have is 5 over 3 radical 2x. So I took that 3 out as a perfect square, which means I only need to multiply by radical 2x, top and bottom, to rationalize. For a final answer of 5 radical 2x over 3 times 2x. So we can even take it one step further. 5 radical 2x over 6x. So here we go again. Radical 2x times radical 2x is just 2x. And the 3 and the 2 can multiply now that they're outside radicals. For a final answer of 5 radical 2x over 6x. Let's try that one more time. I'm going to break this into radical x over radical 12. 12 can break down into 4 and 3. So that becomes 2 radical 3. So what I really have is radical x over 2 radical 3, which means I only need to multiply by radical 3 to rationalize. And that gives me radical 3x over 2 times 3 for a final answer of radical 3x over 6. So the radical 3 times radical 3 is 3. 2 times 3 gives me 6. And that's my final answer. So that's when you just have a single radical. Notice there's no adding or subtracting on any of these. They're just single terms. Now let's look at some where there is some adding and subtracting. So when the denominator has 2 terms, which makes it a binomial, multiply by what's called the conjugate. Kind of like in English class when you conjugate verbs, that's what it makes me think of. I don't think it means the same thing, but it's called the conjugate of the binomial, and I'll teach you what that is. So this one looks different. I have 5 over radical 3 minus 2. And anytime we have a binomial, we saw this in chapter 10, it has to stay together. So what we're going to do is multiply the top and the bottom by radical 3. Instead of minus 2, it's going to be plus 2. It kind of looks like the opposite, but it's just called the conjugate. So the only part that's different is the middle sign from minus to plus. The radical 3 is still positive. It's just the middle sign that changes. And then whatever I put on the bottom, I put the same thing on the top in order to keep the expression equivalent. So then I do some multiplying. 5 times radical 3 is 5 radical 3. And 5 times 2 is 10. On the bottom, I now have a binomial times a binomial, and I'm going to FOIL. So I have radical 3 times radical 3, which remember is just 3. Radical 3 times 2 is positive 2 radical 3. Negative 2 times radical 3 is negative 2 radical 3. And negative 2 times positive 2 is negative 4. I want you to see what happens to the middle two terms. We saw this back in chapter 9. I have positive 2 radical 3 and negative 2 radical 3, which is why we do the conjugate minus and plus. We looked at this when we learned about difference of squares. So those middle two terms are going to cancel or zero out every single time because I'm making them do that by putting the plus and the minus. So I do that on purpose. And then what happens is we have 5 radical 3 plus 10 on top. And I just have 3 minus 4, which is negative 1, on the bottom. And from there, sometimes you can clean things up, sometimes you can't. Because it's negative 1, I can divide both of the outside values by negative 1 and get negative 5 radical 3 minus 10. And that would be your final answer. I don't think they care about the order in my math lab. You might have to switch them because they like the integer first, but I don't think it matters for these. Let's look at the next one. So we have 2 over 3 radical 2 plus 4. Again, we have a binomial on the bottom. So we're going to multiply the top and the bottom by the conjugate of the binomial. So instead of plus, we'll put minus. So 1's plus, 1's minus. These two are always the same because we have to be fair to the top and the bottom. Then we'll multiply out the top. It's going to give me 6 radical 2 minus 8 over... Now on the bottom, you usually use FOIL, which is first, outside, inside, last. I know those middle terms, the outside and the inside, are going to zero out. So at some point, you can just do first and last, because you know the inside outside is going to cancel. You can still do inside outside, but they're going to zero out every time, and it saves you a little bit of work if you just skip that part. Just do first and last. So 3 radical 2 times 3 radical 2 would be 9 times 2. So 3 times 3 is 9. Radical 2 times radical 2 is just 2. And positive 4 times negative 4 is negative 16. So we have 6 radical 2 minus 8 over 9 times 2 is 18. 18 minus 16 is 2. And then you look at the outside numbers, not in the radical, but everything else. The 6 can divide by 2, and the 8 can divide by 2. What's in the radical doesn't matter because we can't divide it anyway. So that gives us 3 radical 2 minus 4 as the final answer. So we multiply by the conjugate to get rid of those radicals on the denominator. Let's look at the next example. I have radical 6 plus 2 on top, it's a binomial, and radical 5 minus radical 3 on the denominator, another binomial. On top doesn't matter, we can have whatever we want on top, it's the denominator we have to focus on. So I'm going to do the conjugate of the denominator, radical 5 plus radical 3, on the top and the bottom. A lot of students will do the conjugate of both. We don't care about the numerator. It's the denominator we're trying to focus on. One needs to be minus, one needs to be plus, and these need to be the same in order to keep the equivalent expression. So we're going to have to FOIL on top, no shortcut. Radical 6 times radical 5 is radical 30. Radical 6 times radical 3 is radical 18. 2 times radical 5 is 2 radical 5, and 2 times radical 3 is 2 radical 3. So fully FOIL the top. On the denominator, we can shortcut a little bit, only because we know the middle terms are going to cancel out. We knew radical 5 times radical 5 and radical 3 times radical 3. Radical 5 times radical 5 is just 5, and negative radical 3 times positive radical 3 is going to be minus 3. Let's see, radical 30 does not have any perfect squares, so I can't do anything. Radical 18, I can break it down a little bit for a final answer of radical 30 plus 3 radical 2 plus 2 radical 5 plus 2 radical 3, all divided by 5 minus 3, which is 2. In order to reduce this anymore, everybody's coefficient has to be even, but this coefficient is 1, and that coefficient is 3, so there's nothing we can do. So when you're not sure, just kind of stop, because you don't want to take it too far. So if all the coefficients, all the integers are not divisible by the denominator, just don't touch it, just leave it alone. Alright, I encourage you to pause the video at this time and try this last one on your own, and then I'll go over it. So we have a binomial and a binomial. We're going to multiply by the conjugate of the denominator, radical 3 minus radical 5. Top and bottom, same thing. The conjugate comes from the opposite side here. We have to fully FOIL the top. Radical 2 times radical 3 is radical 6. Radical 2 times negative radical 5 is negative radical 10. 5 times radical 3 is just 5 radical 3. And 5 times negative radical 5 would be 5 radical, I'm sorry, not plus, it'd be minus. Minus 5 radical 5. The denominator we can shortcut a little bit. Radical 3 times radical 3 is 3. Positive radical 5 times negative radical 5 will be negative 5. Nothing on the top simplifies, so I'm just going to leave it as is. Radical 6 minus radical 10 plus 5 radical 3 minus 5 radical 5. All divided by 3 minus 5, which is negative 2. And these integers do not divide nicely by negative 2, so we're just going to leave it just like that. And that is, it's kind of dividing radicals, but we call it rationalizing denominators.